Hello children, today we will start our this lecture from a new chapter, chemical kinetics. Now there are three types of reactions on the basis of their speed. So the reactions which are taking place in a very fast speed, or you can say instantaneous reaction, or which are taking place at once, and such reactions are taking place between the ions, and that is why these are also known as ionic reactions. So these ionic reactions taking place at once, as for the example, aqueous solution of silver nitrate as far as mixed with aqueous solution of sodium chloride, you will get white ppt of AgCl plus sodium nitrate. So such type of reactions don't take any time for their completion. And in other way, number of reactions are of such type which takes place in a very slow speed. For example, rusting of iron, fermentation are the such type of reactions which takes a very long time for their completion. So reactions which are ionic in nature and taking place at once, and the reactions which are very slow in nature and taking a long time for their completion are not very important or not good to discuss their rate of reaction. But in between these two type of reaction, there are such reactions also which are known as molecular reactions, and these are taking place in moderate speed. Okay, their speed is less than ionic reaction and more than very slow reactions. So such molecular reactions which are taking place with moderate speed. So we discuss the rate of such type of reactions. Okay students, for example, reactions involved in the formation of ammonia, decomposition of hydrogen peroxide, esterification, hydrolysis of esters. So these are the reactions which are taking place with moderate speed. Okay, and the chapter chemical kinetics is going to discuss such reactions, their speed, and the factors which affect the rate of such type of reactions. Okay students, so branch of chemistry which deals with the study of reaction rates and the mechanism by which they occur called chemical kinetics. Okay, so under this branch of chemistry we discuss the rate of reactions which are taking place with moderate speed, or you can say molecular reactions. Okay students, the next heading is scope and importance of chemical kinetics. So in the study of chemical kinetics, we not only study the rate of a chemical reaction but also take into account the course of all physical and chemical processes which occur during the course of reaction. The study of kinetics of a reaction so enables us to elucidate the mechanism of the reaction also. Okay, so the forthcoming discussion of this chapter is going to discuss all these points one by one. Okay, next heading is reaction rate, its measurement and its dependence on various factors. Okay, so rate of the reaction or reaction rate. So as the definition is given here, the rate of a chemical reaction may be defined as the change in concentration. Change in concentration means amount of the reactant or product. Change in concentration of any of the reactants or any of the products per unit time. is known as rate of that particular reaction. So rate of the reaction, mathematical expression, change in concentration of a reactant or a product. So any one of the reactant or any one of the product, and time taken for the change. So this ratio is known as rate of the reaction. Then unit of the rate of reaction, mole per liter per second or mole per liter per minute. But if the reaction is taking place in gases, then atmosphere per second or atmosphere per minute. Okay, students. Now, during the kinetic studies of chemical reactions, two types of rates of reaction are generally used. Two types of rate of reaction. These are average rate and instantaneous rate. So, average rate is the rate of a reaction for a time interval, and instantaneous rate is the rate of reaction at a particular pinpoint time. A brief description of these rates is given here. So first heading is average rate of a reaction. Average rate. So according to the definition, the change in concentration of any of the reactants or any of the products per unit time over a specified interval of time is called the average rate of the reaction. Okay, students. So the average rate of a reaction is obtained by dividing the change in concentration of a reactant or a product by the time interval in which the change has occurred. So the average rate, mathematical expression, change in concentration of a reactant or a product divided by time interval involved in the change. Okay, for example, if in a reaction A is a reactant and is forming B. Okay, so for this reaction, the rate of reaction can be expressed as first in the terms of decrease in the concentration of A. Okay, students. So as you all know that with the time, amount of this A reactant will decrease and the amount of this B product will increase. Okay, so first we are going to discuss average rate in the terms of decrease in the concentration of the reactant. So average rate of reaction will be equals to change or decrease in concentration of A divided by the time involved or change in time. Okay, students. So next, the concentration of a species is represented by enclosing its formula in square brackets in this way. And when we write any species in square bracket, means we are representing that species in the terms of molar concentration. Okay, students. Now suppose A1 is the concentration of A in mole per liter and time is T1, and it changes, the concentration changes in the form of A2 after time T2. Then the change in concentration will be A2 minus A1, that we can represent as delta A, and the change in time will be T2 minus T1, that will be equals to delta T. So this delta is showing the change or the difference from the initial to from the final to initial state. Okay, now we know that the value of A2 will be less than A1. Why? A2 is the concentration, A1 is also the concentration, but A1 is the initial concentration and A2 is the final concentration. And we all know with the time the amount of reactant will decrease. So A2 will be less than A1. Okay, students. So since the rate of a reaction is always expressed as a positive quantity, a negative sign is put before delta A to make the rate positive. Okay, so when we are going to write any reaction rate in the terms of reactant then we will put a minus sign before the concentration change. Okay, hence the average rate of the above reaction in terms of A can be expressed as change in concentration minus delta A divided by change in time interval, that is delta T. Okay students, then in the terms of increase in the concentration of B, so with the time amount of product will increase, so the average rate will be change in concentration of B divided by time interval involved. So if the change in concentration is delta B and change in time is delta T, then the average rate in the terms of product will be delta B divided by delta T. Okay students, so delta B is positive because the concentration of B increases with time, hence the rate is positive and there is no need to put a negative sign before delta B. Okay students, then since the rate of disappearance of A is the same as the rate of appearance of B, so it means average rate of reaction in the terms of reactant will be equals to the in the terms of product. Okay students, then we are going to discuss few examples on the basis of this discussion only. We are going to apply this concept of expressing the average rate of reaction to some specific chemical reactions. Okay, and the first is reactions involving the same stoichiometric coefficients of reactants and products. So such reactions where the stoichiometric coefficients of the reactant and products are same, 1 1 1. So such reactions are expressed simply as in the terms of CO, we can write average rate of reaction as minus delta CO upon delta T. Okay, this is the CO is the product, so minus sign will be there, and in the terms of Cl2 we can write in this way, minus delta Cl2 upon dt. But if we want to write in the terms of reactant, then it will be delta COCl2 upon dt. Okay students, but if reactions involving different stoichiometric coefficients of reactants and products, then what will happen? For example, in the formation of ammonia, you can see here that N2 plus 3H2 is forming 2NH3. So these are having different stoichiometric coefficients. So the stoichiometric coefficients of N2, H2 and NH3 are 1, 3 and 2 respectively. This implies that 2 moles of ammonia will be formed only when 1 mole of nitrogen and 3 moles of hydrogen disappears. Okay, hence the rate of appearance of ammonia is twice the rate of disappearance of nitrogen and 2 by 3 times the rate of disappearance of hydrogen. So we have to equalize these formation and disappearance rate of reaction. Okay, so we will write the rate expression for such type of reactions where stoichiometric coefficients are different. So for ammonia we will divide the related unit, chemical unit, with its coefficient, So we can write in this way that N2 minus delta N2 upon delta T equals to 1 by 3 minus delta H2 upon delta T, and again it will be equals to 1 by 2 delta NH3 upon delta T. Okay, so this will be the rate expression for such type of reactions in which coefficients are different. Okay students, the next type of rate reaction is instantaneous rate of a reaction. instantaneous rate of reaction. So as the name is indicating, instantaneous, at once, at a particular pinpoint time. Okay, so according to definition, the rate of change of concentration of any of the reactants or products at a particular instant of time is called the instantaneous rate of the given reaction at that instant of time. Okay, for the determination of instantaneous rate, the time interval delta t should be as small as possible, so that there is the least possible change in the rate of reaction over that time interval. So that time interval should be as small as possible. Okay, and it should be limiting towards the 0. Okay, so instantaneous rate will be equals to average rate when the change in time is limiting towards to 0. Okay, so in mathematics, very small changes are represented by d instead of delta. Using the standard calculus notation, the instantaneous rate for the reaction A is forming B can be expressed as minus dA upon dt equals to dB upon dt. So this is the rate expression in the terms of reactant, and this is in the terms of product, and these two rate expressions will be equals to each other. Okay, so where d delta dA and dB respectively represent infinitely small changes, very small changes in the molar concentrations. Okay, students. Then next is experimental determination of reaction rate. So we can represent the rate of reaction experimentally with the help of a graph. So as you can see here, determination of the average rate of reaction. So this A is showing average rate of the reaction in the terms of reactant, and this is showing in the terms of product. So T is on the x-axis and change in concentration on the y-axis. So at T1 the concentration was x1, and at T2 concentration was x2. Okay, students. So the average rate in the terms of reactant will be delta x upon dt, and this delta x will be equals to final concentration minus initial concentration divided by final time minus initial time. Okay, and same way in the terms of product, it will be equals to delta x upon delta t will be equals to x2 minus x1 upon t2 minus t1. Okay, students. Then next heading, determination of instantaneous rate of reaction. So for the determination of instantaneous rate in the terms of reactant, we will take a particular time t dash, and at this time, against this time, we will take a point here on this curve, and on this curve, okay, at this curve we will draw a tangent. In this way, and the value of this slope will be equals to the instantaneous rate of the reaction in the terms of reactant. Okay, students. So this slope will be equals to value of slope will be equals to, this is given already here, this slope is given. So the value of slope will be equals to OA upon OB. Okay students, so you can write here also, this is AOB. So OA upon OB will be the value of slope, and this value will be equals to the instantaneous rate of the reaction. Then next heading is factors which affect the reaction rate, and first is nature of the reactant. So the reactions involving ionic or polar substances are very fast because the electrostatic forces existing in their molecules are easily broken in aqueous solution. A chemical reaction involving covalent reactants involves the breaking of old bonds and the formation of new bonds, that is the rearrangement of bonds, and therefore when a reaction involves the rearrangement of bonds, the rate of reaction depends upon the ease which the specific bonds are broken or formed. So such type of reactions are taking more time in comparison to ionic reactions. Okay, so in short we can say that ionic compounds or ionic compounds and polar compounds. So ionic compounds will have higher rate of reaction, polar compounds lower than ionic but still higher, but covalent compounds will have low rate of reaction or lowest rate of reaction out of these three. The next is concentration of the reactants. So rate of reaction is proportional to concentration of the reactants. Okay, if the amount of the reactants will be greater, the rate of reaction will be also higher. The next is temperature. So for temperature also the rate of the reaction is proportional to temperature. So with increase in temperature, rate of reaction also increases. Then surface area of the reactants. If the surface area of the reactants is higher, rate of reaction will be also higher. Okay students. Then presence of catalyst. A catalyst increases the rate of reaction. This is because it provides an alternative path with a lower energy barrier. Okay students, so catalyst also increase the rate of reaction, as you can see with the help of this presentation here graphically. So these are the peaks, energy barriers, and here particular compounds are formed. Reactant form compound with catalyst. Okay, so to if reactant want to convert in the form of product, they have to cross this energy barrier, and only those reactant molecules can convert in the form of product which are having such sufficient amount of energy through which they can cross this energy barrier. Okay students, but in the presence of catalyst, this energy barrier changes and it becomes little lower. So more amount of reactant can cross this new energy barrier, and that is why rate of reaction become higher in the presence of catalyst. Then dependence of reaction rate of concentration of reactants, and this we can discuss on the basis of law of mass action. So according to this law of mass action, which is given by Goldberg and Wage, that at constant temperature the rate of a chemical reaction is directly proportional to the product of active masses of reacting species, with each active mass term raised to the power equal to the stoichiometric coefficient of the species in the chemical reaction. Okay students, so if such a reaction, hypothetical reaction is taking place, and you can see here in this reaction, these reactant units are having A, B and C as the stoichiometric coefficients. So their rate expression according to rate law will be, rate of the reaction will be proportional to A to the power A, B to the power B and C raised to the power C. Okay, and rate of a reaction will be equals to K, A raised to the power A, B raised to the power B and C raised to the power C. So this is the rate expression according to rate law. Okay, according to law of mass action, not rate law. It is according to the law of mass action. Okay, the next term is active mass. So molar concentration of any substance is considered as its active mass, and we are going to follow this statement only, that we will take active masses of the substance, active masses as the substance as their molar concentration. Okay students, the next is rate law and rate constant. So what is rate law? The mathematical expression which describes the experimentally observed dependence of the reaction rate on the molar concentration of the reactants is called the rate law or rate equation. So students, the most important term which is coming here is experimentally observed. Okay, so law of mass action is a theoretical value for a given reaction. Okay, but the rate law is experimentally observed dependence of the reaction rate on the molar concentration. Okay, so this is the difference between rate law and law of mass action. So according to this rate law, rate of the reaction will be equals to K and concentration of the reactant raised to the experimental power of that unit. Okay, for example, N2N2O5 is forming 4NO2 plus O2, but the rate of the reaction according to rate law is rate equals to KN2O5. So we are not using this power here in the form of power, because according to experimental data, the dependence of the change in concentration of N2O5 is raised to the power just 1. Okay students, so experimentally it has been observed that the rate of this reaction gets doubled when the concentration of N2O5 is doubled. Okay, so the rate law written above agree with all these facts. In general, if this is a reaction, so we can express its rate law as K A to the power P and B raised to the power Q. So as you can see here that these powers can be similar to these stoichiometric coefficients or can be different also. So most of the time these are different here. Okay students, then for example, rate law for this reaction which is determined experimentally is rate equals to KNO2 NO raised to the power 2 H2 raised to the power 1. It means against to hydrogen, the rate of this particular reaction is of first order, and against to this NO, the rate of reaction is of second order. Okay students, so we are going to use these powers further as order of reaction. Okay, so as you can see here, order of a reaction. So the power to which the concentration term of a particular reactant in the rate law is raised is called the order of reaction with respect to that reactant, and the sum of all the powers to which all the concentration terms in the rate law are raised to express the observed rate of reaction is called the overall order of reaction. Okay students, so for example here the order of reaction of this reaction in the terms of NO is 2 and in the terms of hydrogen is 1, and the overall order of this reaction will be 2 plus 1 equals to 3. Okay students, same way for this reaction the rate law is this. So the order of reaction in the terms of NO is 2 and in the terms of O2 is 1, and overall order is 2 plus 1 is 3. Okay students, here this is the reaction and the rate law of this reaction is this: K CH3CHO power is 3 by 2. So the order of this reaction is 3 by 2. Okay students, then rate constant or velocity constant. Rate constant, velocity constant, specific reaction rate. So the constant K appearing in the expressions this for the rate law of a reaction is called rate constant or velocity constant. It is also referred to as specific reaction rate. Okay students, now according to definition, the rate constant of a reaction is equal to the rate of reaction when the concentration of each of the reactant is unity. As you can see here, if the rate expression of any reaction is this and the concentration of all the units is unity, then rate of the reaction will be equals to K. Okay students, then characteristics of rate constant. First is rate constant is a measure of the rate of reaction. Higher the value of K, greater is the rate of reaction. Then second point, a particular reaction has a definite value of K at a particular temperature. The value of rate constant for a particular reaction increases with increase in temperature. So K depend upon the temperature. The rate constant does not depend upon the initial concentration of the reactant. Okay students, so rate constant depend upon the temperature but not on the initial concentration. And the most important point, its units depend upon the overall order of reaction. For a reaction of order n, the units of rate constant will be this. So the unit of rate constant will depend upon overall order of the reaction. Okay, the next heading is difference between reaction rate and specific reaction rate. So reaction rate means rate of reaction and specific reaction rate means rate constant. So first point, it is the rate of change of concentration of a reactant or product with respect to time. But the specific reaction rate is the constant of proportionality and equal to the rate of reaction when the reactants units are in unity. The reaction rate at a particular instant depends upon the concentration of reactant at that instant, but the specific reaction rate is independent from the initial concentration of the reactant. Okay students, then rate of reaction or reaction rate is having a fixed unit, mole per liter per second, but specific reaction rate is having different units depending upon the order of the reaction. Okay students, thank you.